Hey everyone, this week we will be continuing on with more statcast data. This time we're going to make some cool visual plots, and thanks to a certain person we can make these visual plots a little bit easier. We don't have to figure out a long way to write code, but we'll get started. Make sure you load in from the previous video the statcast hitting data. There's two ways you can do it. In the last video, I made a CSV file. You can load it that way by doing read CSV, make sure strings as factors is false, or the other way, the way I prefer, is loading through a database because it's quicker. So how we do that is we'll load in our libraries, our SQLite and our DBI package from last video, and we'll connect to a SQLite database. In this case, my database name is SQLite, and then we'll create a data frame called HData, which is hitting data, and our connection is that database, and select star, which means we'll select every observation from our table, which is statcast hitting. So we'll do this pretty quickly. Now we can load in the necessary libraries, and how we do that is make sure we have DevTools installed at the very least. Remove the comment to install those packages of DevTools. Then our special someone today is Jim Albert, who helped write the Baseball with R books. Great resource to use. I've used it before, and it's magnificent. Helped me through a lot of this, and it definitely helped me with what I'm doing now in terms of code. But feel free to check out his WordPress site right here. Baseball with R WordPress Baseball, and it's a great resource to use. I use it still to this day. I'm learning more and more things every day. But anyways, and then after we install DevTools, we'll call the DevTools package by installing GitHub. And this package, baseball called strike, will help us make these heat map plots I've made on Twitter. Fun fact, I was doing the long way of making these heat maps when it came to turn out that Jim Albert already made these plots with those heat maps, and I kind of mirrored it without even noticing it until, looking at his WordPress site. And so it made my running of this code a lot easier. And again, if you haven't installed GitHub already, but if you watched my previous video, you should have it installed already, so you don't have to worry about this. But Baseball R from Bill Petty, insanely great package to use in terms of coding baseball data with R. There's so many features you can use with it. And then to use the called strike package, we'll use MGCV, which is part of rendering these plots and these probabilities. So if you haven't installed that, install that as well, and then we'll run these libraries, call them into the plot, and so we will create various plots. First, we'll start off with spray angle, and what spray angle essentially tries to convey is it goes from, I think, -40 to 40, and -40 is being a ball hit to left field, 40 is being a ball hit down the right field line, so on and so forth. And what the spray angle plot kind of conveys is where the ball is hit, where it's pitched. So you know how that saying where some guys will hit it where it's pitched. This is a great way of displaying that. So what we're going to do is create a few plots. Like we're going to do it for the entire league of right-handed hitters, left-handed hitters, and then we're actually going to focus in on the AL and NL MVPs in Cody Bellinger and Mike Trout. So we'll say league, we'll say R for right-handed, and SA. And we'll say SA plot, which is the spray angle plot. Our data is H data, which is the hitting data, and this is where we can, without having to create another data frame of filtering, we can filter within that call. So we'll say filter, in this case stand, which is the batter stance. We'll say right, and then our title gives us that option, and we'll say league spray angle of right-handed hitters. And so we'll run this plot real quick just to see what it looks like. And we can see by calling league RSA in our line of code, we can see that for right-handed hitters, as the ball goes up and away, they typically will go the other way with it. It's pretty linear in terms of that case. But as the ball is pitched down and in, they will tend to pull the ball to, say, third base, and as it's pitched up and away, they'll tend to hit the ball the opposite field towards first base. So pretty cool stuff. Now we can call a plot of Mike Trout's spray angle. So how we do that is we'll say RSA to keep it generalized, so right-handed spray angle. Another spray angle plot. Again, H data. And again, we'll create another filter. This time our player name is Mike Trout. So we have Mike Trout. And then our title will be Mike Trout spray angle. Can't spell spray. And I forgot to add the spray angle right-handed hitters. But we can have this as well. And I'll run this, and I'll show you a side-by-side plot real quick. So we have the RSA in. Now we can install or call ggpubber. Now there's two different ways you can do this in terms of arranging multiple plots side by side or up and down. There's a grid arrange function, which is a base call, but there's also a ggpubber function called ggarrange. I prefer that because it's more robust. So you can install ggpubber if you haven't already. I have, so I'll just call it in my library. So ggpubber, and then we can do a ggarrange, and this time we can do league RSA RSA, and we can see the plots side by side. After we zoom in, we can see it a little more clearly. We can see that our league spray of right-handed hitters is pretty linear to last time. Mike Trout's looks like that he'll really pull the ball if it's up and in, and as the ball is pitched away, you can see the axes are a little bit different. So as the ball is pitched away, he'll typically hit it up the middle. So he's more of a pull up the middle type hitter compared to the league spray angle. Now we can continue on, and this time we'll do Cody Bellinger plus the league spray angle. So again, I'll just copy and paste. Feel free to type it out if you want, but we'll say league left-handed spray angle. So I'll say spray angle of left-handed hitters, and then same for LSA, left spray angle. We'll change this to Cody Bellinger. And again, it'll take a minute or two to run, but we'll have it ready to go. Now that we have it ready to go, we can again go into the ggarrange. We'll do league LSA, LSA. And again, once we zoom, we will be able to see this plot. So now we see the league spray angle of left-handed hitters. So you see, similar to right-handed hitters, as the ball goes up and away, they will tend to hit the ball further away from first base. Cody Bellinger's looks somewhat similar to the league spray angle. Looks like that, as the ball goes down and in, he'll tend to pull it towards first base, and as the ball goes away, he'll tend to take it the other way. Now, once we're really good, we can actually combine multiple plots all together. So what we'll do is we'll combine Trout and Bellinger spray angle plus the leagues for batter handedness. How we do that is we'll call each plot, and then we'll say number of rows equals 2, number of columns also equals 2. And we'll call that through the GG arrange. We can see that they're all together. Once we zoom in, we can see exactly what it is. Now we can see side by side comparing Mike Trout, Cody Bellinger, their spray angle, their various spray angles, and comparing it with the league of their batting handedness. In this case, Mike Trout is a right-handed hitter and Cody Bellinger is a left-handed hitter. Now we can make a multitude of other plots. So what we're going to do now is I'm going to make a exit velocity plot, launch angle plot, and a home run probability plot. And then we're going to arrange them into one large plot so we can see exactly where in the zone does Trout and Bellinger hit the ball hard, what's their launch angle in those zones, and where is it most likely to be a home run. So essentially this is going to be a lot of copy and paste, but we'll do league, we'll say left-handed EV. We'll do a LS plot, which is a launch speed, which is exit velocity. And again, we'll just copy and paste, and we'll change the variables ever so slightly. So league, exit velo of left-handed hitters in this case, and then similarly we'll do launch speed plot, say exit velo of Cody Bellinger, similarly for right-handed. So let me change that to LEV. So league, REV, and again we'll do, instead of a spray angle plot, we'll do launch speed plot, league, exit velo of right-handed hitters, and then say rev LS plot. This time we'll do H data, Mike Trout, exit velocity. So you can kind of see where this is going. To save time, I've added the other plots. So you can see the launch speed plot, which is exit velocity, launch angle plot, and then home run probability plot. The code's pretty much the same. You just change whatever variable you want to look at. So like exit velo, spray angle, launch angle, home run probability. So we'll run all these that we haven't ran already. Now that we have our plots listed under a name, we can combine it in one big plot. So we're going to do obviously a GG arrange, and we're going to put it all into one big call. We'll run this. With the plot, we can definitely see a lot going on here, and we can make a lot of insightful comparisons. So we can see that Cody Bellinger's exit velocity heat maps are a lot similar to the league exit velocity of left-handed hitters. And similarly, his launch angle, except it's a little bit higher when you go up and in the zone, and slightly down compared to the league. As well as the home run probability for Cody Bellinger greatly increases on pitches up and slightly away, whereas meatballs right down the middle is the highest probability for left-handed hitters. And Bellinger has about 3 times the probability of a home run than the league. And then we can see Mike Trout is roughly the same lines. Mike Trout has a bigger exit velocity, as you can see here by this chart, and compared to the league, and his launch angle is a lot bigger compared to the league, and it's higher on pitches up and away, whereas pitches up and in are at about, give or take, between 30 and 40 degrees, whereas the average launch angle for right-handed hitters is between 20 and 30. And you can see Mike Trout's home run probability is highest when the ball is up and away, about 4 times higher than the highest league average for right-handed hitters. Thanks for watching. Feel free to like and subscribe if you like this content, and we will go over more cool stuff next week.